Times. Generalmente escribo sobre espacio exterior, la química, la geología, la física, pero uno de mis temas preferidos, la ciencia de la whisky. Whisky. Desafortunadamente, todavía me queda bastante español que aprender, así que voy a tener que seguir la conversación en inglés. Thank you very much, and I hope someone can translate that back to English for me. I'd like to thank the organizers for inviting me to this wonderful talk in this wonderful place. So last week, you might have noticed there was an article about water on Mars. It was on the front page of the New York Times. Maybe you've even read it. So the great thing about the internet, or sometimes the bad thing about the internet in this digital world, is that now we know exactly how many people read a story on our website, on the phones, on the tablets. So in the past, we knew that the New York Times sold perhaps 1 million copies, and I, as a reporter, could just imagine that every one of those 1 million people who bought the newspaper read my article. That's not true anymore, because now we know that for some stories, perhaps it's only hundreds or thousands of people who read the story. Sometimes it's 10,000 or 20,000. That's pretty good. If you have 100,000 people to click on a story, that's actually a very good story. So for Mars, this one story was 2.1 million readers. And then, so you might think, why? Why does anyone care about Mars anyway? Whoops. That's interesting. Okay, so because here in La Palma, this island is surrounded by an ocean, which is as much salty water as you could possibly want. On Mars today, there is no oceans, there are no lakes, there are no streams, not even puddles. All the scientists found were a few damp spots of salty water on Mars. So why was this front page news? Why was that so important? And ultimately, it was because it was asking some bigger questions about things. And this is why science is so fascinating. So let me just talk about what I mean by, so this is a conference about frontier science. So let me try to define what I mean by science. And this may not be what other people here mean, and I'm going to define it in terms of what it is not. So health is something that can kill you. Technology is something that can kill someone else. And science is everything else that doesn't have a practical purpose. But again, people do care about this, and this is because we as human beings wonder about things. It's not, even though we can be very cynical about the modern world, that all everyone cares about on the internet is clicking on a short story to find out what happened with the movie stars, with what's going on in the latest politics, or they only care about how the stock market is doing today. But that's not necessarily true. So this is why I got into science writing. So I used to be a physicist. I actually wanted to study physics for a very simple reason, which was I wanted to understand the universe. And physics, of course, is studying the smallest bits of the universe, trying to break it down into the most fundamental laws. And as physicists will tell you, once you figure that out, everything else is just computation. But I wasn't a very good physicist because I didn't have a very good brain for keeping track of details that you need to do to become a very good scientist. And so when I was trying to chase all down these details, I sort of lost track of the big picture. And this is why I think it's an important part about communicating science is conveying the big picture. So, which is part of what drives scientists crazy when you write about them, because for scientists, the details matter. The details matter, a few sigma of difference of probabilities is the difference between a good, solid scientific result and something that is just noise. But when I'm communicating science, that's not what I have to convey. I have to convey what the big picture is and why people care. And the good thing is that in science, there's very often a big picture to convey, unlike politics, sports, entertainment. And as an example, here's today's front page news. Oh, this is the other thing about science is that it's not depressing, it's a lot of news. So here we have the front page with ISIS, the bombing in Afghanistan, and all in all, not the happiest news. And I think this front page from a couple months ago was much better when NASA's New Horizons spacecraft flew by Pluto. So as I was saying, in science, the details matter, but when communicating science, here I say clarity is inversely proportional to precision, and one of the things when you're communicating science is not to say inversely proportional. But again, I don't want to be caught up in details, and it's important for me to try to convey a few things. In fact, when I write a story, I've tried to remember that if I can get people to remember 3 things that in this science things in the story, I've been actually quite successful. In fact, that may be overly optimistic. It may just be 1. So for the Mars story, for instance, the 3 things I would like to have conveyed is, 1 is that there's liquid water on Mars. 2, that with liquid water, you have the possibility of life. And 3, hey, there might actually be life on Mars today. And even if I didn't succeed there, a lot of people walked away from that story remembering that there's water on Mars, which is kind of cool. Okay, so I was also going to talk about neutrinos, because it was a fairly obscure topic until yesterday when the Nobel Prize for neutrinos. So when I started writing this talk, it made much more sense to use neutrinos. But neutrinos are this particle that most people have never heard of. They weigh almost nothing. They come in 3 types. There's an electron neutrino, a muon neutrino, and a tau neutrino. And they do almost nothing in the universe. And here I'm just citing some properties of neutrinos. And it sounds kind of boring. And you might start wondering, why is he talking about neutrinos? Why should anyone care about neutrinos? Why are scientists spending millions and millions of dollars trying to study neutrinos? But the bigger picture is actually much more interesting. So first, one of the things you can do to try to interest people in a topic that they don't understand or don't have a familiarity with is to try to hook them with one of the details that is very interesting. So for example, neutrinos, the sun is continuously producing a gazillion neutrinos. In fact, it's so many that there's probably billions or trillions of neutrinos passing through each and every one of you every second. So, as I was saying before, neutrinos don't interact with anything. In this case, it's a very good thing, or they would really hurt. And then the other thing is that there's this, it may cast light on one of the biggest mysteries in the universe. So if you think back to the Big Bang 13.7 billion years ago, there was a Big Bang, the burst of energy into the universe. There should have been about equal parts of matter and antimatter that formed as the energy cooled. And if you think about it, matter and antimatter, when they come together, they annihilate. And proof that should have destroyed everything, and that would have been the history of the universe. But here we are 13.7 billion years later, and we're all made of matter. So something happened so that in the fundamental laws of physics, so that there was slightly more matter than antimatter that got left over, enough to form all the stars, the planets, and us. So that's sort of things I try to highlight. And you notice the headline doesn't have neutrinos. And this was an article about a result that came out of Fermilab, which was very ambiguous. They didn't quite find what they were expecting to find. It didn't fit any of their theories. And so I basically had to write a story about that they spent a lot of money to find something they didn't understand. But it's still, I was trying to explain that this still played an important part in understanding how the universe came about. I'll mention this in passing since it's in the title of my talk. It's similar with the Higgs boson. So this was discovered a couple years ago. My colleague, Dennis Overby, wrote this long, filled up the entire science section with stories about the Higgs boson. And again, most people, if you're not a physicist, you have no idea what a boson is. If you've been paying close attention, you would know Higgs is Peter Higgs, the physicist who was among the people who first came up idea for why there would have to be a Higgs boson, because otherwise the equations, all the particles would be massless, and that kind of makes it difficult for gravity to work or do anything interesting like form stars and galaxies. But so, again, in science writing, you can always convey, there's a lot of times when you can convey wonder. Dinosaurs. Again, this is, if physics is wondering how everything is, dinosaurs, archaeology is wondering what was the past like? How did these huge animals live in the past? Where did we come from? It's amazing. If I can just put dinosaurs in a story in the headline, I get lots of readers. It doesn't matter what else it says. Again, Pluto is also always a popular topic. And this was sort of an interesting story of how I came about this, in that this was a story back in 2001. The American Museum of Natural History had just redone its exhibits, and they were sort of the first to leave Pluto out as a planet. And they opened their big new exhibit in the year 2000. 1 year passed, and almost no one noticed. And until I believe one of our sports writers went by with some kids, probably his son or so. They were looking for Pluto and they couldn't find it. And so then he called the science editor and the science editor turned to me and said, go find out what's up. And so I called it the museum, and they were confused because they were like, we haven't changed anything recently. And then I did the research and came with this article, and this became a big thing. But this wasn't something that was tied to a journal article or a news event. Again, the news event was the museum opening a year later. So this is one of the things, a lot of the stories come from people telling me about it. So one of the things I wanted to say is, so when I was coming here, I sent a questionnaire for me to fill out to help people about me and what I thought about science writing. One of the questions was, what do you know about Spanish science? And my answer was, quite honestly, I really don't know very much. And I was thinking back, I don't recall receiving press releases or ever receiving a phone call from a press officer from a Spanish science institution. So this is an invitation. If you have news, please give me a call. So other things that people wonder about are, in biology, it's one of the easier subjects because you can talk about what's the beginning of life, what causes cancer, how can we live longer and such. This was a rather interesting story. I don't know if you had this issue in Spain, but in the United States, there are a large number of people who don't believe in evolution and are are trying to dilute the teaching of evolution in schools. And this goes under the name of intelligent design. So a few years ago, we were discussing, there's a whole discussion in the newsroom about how we should cover it. And I made the mistake of proposing the idea of let's write about the science of intelligent design and try to probe it. So I actually tried to do a story. It's on the front page. It's got a lot of feedback. I must say that biologists are a very tough crowd to deal with. And I'll briefly say what not to do. So things I try not to do is to overhype a story. I want to highlight the wonder of it, but I don't want to exaggerate what's going on. Another thing you often try to do is try to just point out what the practical applications of this, but it also is important to try to do it in a way that, that is useful. And here's a quick example. High temperature superconductors. They were discovered 20 years ago, I believe, actually, and people still don't actually understand what they are. But for a while, there was this whole series of experiments where they were kept on increasing the temperature or raising the temperature where the superconductors would work. And every news story would say, could one day lead to levitating trains. And that was always an effort from the reporter to try to indicate a practical purpose. As most of you probably noticed, there aren't too many levitating trains in the world. So really we didn't actually capture what was interesting about the materials and what their potential uses were. So other topics are a little bit harder. So for example, math. Math is very abstract. It's, when you talk to mathematicians, they often can't even explain what another mathematician's work is. And my brother's a mathematician, so he's always trying to explain things. And one time he was explaining to me that it was so hard that mathematicians couldn't even follow proofs anymore. And this struck me as an interesting idea because when we go to school, we learn about Euclidean geometry, and math proofs are a very step-by-step process, and you could clearly see this proof was a proof or it didn't work. But apparently that's not true anymore. And this led to a story exploring about the nature of proofs, and that a proof was no longer an ironclad steps that led to an immutable truth. Chemistry is another interesting one. It's hard to do chemistry because a lot of times chemistry is one molecule with a very long name combined with another molecule with a very long name, producing another one, and end up producing something very useful. So a few years ago, 5 years ago, today's Nobel Prize in chemistry, so we can find out about half an hour, I believe, or an hour. So in 2010, I wake up at 6 o'clock in the morning in New York. I go to the Nobel Prize website and I see this. Palladium catalyzed cross-couplings in organic synthesis, and I'm going, what the heck? And amazingly, by the end of the day, I have this. It's a very nice article in the New York Times, and people read it and they think I know what I'm talking about, which is great. But at other times, this, again, looking for big picture questions. Here's a story. I was at a conference, and there was a talk about glass. Why is glass solid? Because it has the same molecular structure as a liquid. All the atoms are jumbled with no order. And fascinatingly, there's still not a good scientific definition of why glass is solid. And that was one of the few times I could read about this chemistry, physics, where everyone knows what the question is. And I can use that to carry people through the somewhat complicated science and hopefully they can pick out a few facts. So for one, the old cathedral windows in Europe, sometimes they're thicker at the bottom. That's not because the glass had flowed. They actually were made that way. Science reporting is still very important at the New York Times. So at the New York Times, we still have, I believe, 17 reporters, 5 editors. We have a web producer. We have an art director. We have a photo editor. So that's actually a very large staff. I believe it's probably the largest one-ad newspaper in the world. It started in 1978 with our weekly science section. And back for the 25th anniversary of that, back in 2003, the science section put together this special issue. And interestingly, we didn't look too much at the past and saying, oh, look at what these great stories we've written. We tried to lay out 25 questions that we thought were so interesting and for people to be thinking about for the future. I'll just quickly go through them. Most of them haven't been answered yet, except for number 1, does science matter? Of course it does. But all these, will humans ever visit Mars? It's still not clear. Some others. Number 12, I'm sure a lot of you would think have an answer. Probably everyone disagrees what the answer should be. Are men necessary or women necessary? Why do we sleep? Can robots become conscious? And how did life begin? Should we improve our genome? Do paranormal phenomena exist? So there's still a lot for us to be wondering about, and this gives us a lot of things for scientists to be discussing about with people in the future. So the big questions are still, who are we? Where are we now? Where do we go? And what does the future hold? Thank you very much.